Welcome. Today we will be proving the Heron's formula for the area of the triangle. And first thing first, let's prove that for any triangle the following formula for a surface of the triangle is true. Okay, so first thing first, we can notice that sinus of alpha angle is nothing like h, which is the height of our triangle, over a, which is the side length of the triangle ABC. So the height of our triangle A, B, and C is nothing like a times sinus of alpha angle. Right, so if we want to prove that this equality is true, it's convenient to use well-known formula for the area, which is the side length C times height h over 2. Right, and now the only thing we need to do is to substitute a times sinus alpha angle in place of h. So we got c times a sinus alpha over 2. And this equality is already proved. Right, since we know this formula for the area of the triangle is true, we can start proving our Heron's formula. So, first thing first, let's use the cosine theorem for side length b. So we got nothing like b squared is equal to a squared plus c squared minus 2ac times cosinus of alpha angle. Right, and the next thing is to extract the cosinus alpha from the given equality. Right, so the cosinus alpha is nothing like b squared minus a squared minus c squared over minus 2 times a times c. Okay, the next thing is to use the trigonometric identity, which is nothing like sinus squared alpha angle plus cosinus squared alpha angle is equal to 1. And since alpha is between 0 degrees to 180, we can see that sinus alpha is nothing like square root of 1 minus cosinus squared alpha angle. Right, so now using the formula for difference of the squares, we've got one minus cosinus alpha, so it's actually 1 plus b squared minus a squared minus c squared over 2ac. And the next thing is 1 plus cosinus alpha, so it's actually 1 minus this part. Right, so we get 1 minus b squared minus a squared minus c squared over 2ac. Okay. So now let's make place for our proof right over here. So the sinus alpha is equal to square root of 2ac plus b squared minus a squared minus c squared over 2ac times 2ac minus b squared plus a squared plus c squared over 2ac. Okay, so our sinus alpha is nothing like b squared minus a minus c squared times a plus c squared minus b squared. Okay, over 4a squared c squared. Now let's use a formula for a difference of these squares second time. So we got sinus alpha is equal to square root of b minus a plus c times b plus a minus c times a plus c minus b times a plus c plus b. Over 4a squared c squared. Next thing is that we need to write each of these sums in the brackets in terms of the half of the circumference of this triangle. Right? So we've got b minus a plus c is nothing like b, which is half of the circumference of the triangle, times 2 and minus 2a. Similarly, we got b plus c plus a is just 2 times half of the circumference, which is basically the circumference of the triangle, of course. Alright, so that next thing, b plus a minus c is equals to 2b minus 2c. And the last part is a plus c minus b is 2p minus 2b. Right. And let's substitute it to our brackets. So we got nothing like 1 over 2 times a times c, because the square of the quotient of numbers is the quotient of the squares. Right? And under the square root, we've got nothing like this times this times this times this. So 2 times p minus a times 2p times 2 times p minus c times 2 times p minus b. Okay, and under this square root we've got 2 to the power 3. So behind the square root we've got nothing like 2. So sinus alpha is basically 1 over AC times 2 times square root of pi times pi minus a times pi minus b times b minus c. Okay, and now let's substitute the sinus alpha in our formula for a triangle, which we proved at the beginning of this proof. Right, so we've got AC sinus alpha over 2 is equal to AC over 2 times sinus alpha, so times 2 over AC times square root of b times b minus a times b minus b times b minus c. Okay, this cancels out, obviously, because the silences are positive numbers, and we are left with the phases. Thank you for the presence, thank you for watching, and see you next time.